Okay, today is lesson 3, day 2. We're continuing to graph the equation y equals f of x, starting with warm-up 2. Alright, so Ms. Fox asked your class, is the sum of 4.2 and the square root of 2 rational or irrational? Patrick answered that the sum would be irrational. State whether he's correct or incorrect and justify your reasoning. So thinking back to what we talked about for this other warm-up, you know the only way that an addition problem can get you an irrational number is if one or both parts is irrational. So the only way to get an irrational sum is if both parts are rational. So looking at our two numbers, I know 4.2 is rational. It's a terminating decimal. Square root of 2, we just went through that yesterday. It's not a perfect square, so it comes up as this decimal that goes on forever with no pattern. So that's irrational, which means that if I add them together, I get an irrational number. So we're going to say that Patrick is correct. And for my reasoning, the square root of 2 is irrational. So the sum is irrational. Lesson 3, day 2 notes. This is going to be a little bit of work just since the graph is so big, so you'll have to bear with me. We are continuing the increasing or decreasing. We first need to consider this function, f of x equals x times x plus 4 times x minus 4. We want to find a table of values and plot that function on the coordinate plane over the interval from -5 to 5. So this part right here is really important. We're being asked to create a table and graph this. We are only doing -5 to 5. Means when we actually graph it, we will stop at these endpoints. We won't go past it when we do our domain and range and all that. We won't go past them. We have to stay in that interval. So to begin, we need to use our calculator. Put our function into the y equals. So it said f of x is x times x plus 4 times x minus 4. Looking at the graph so we know what it should look like. I can see it's a little big, so I'm going to press zoom, choose number 3, and hit enter to zoom out. And now I see that general shape. It's curvy. See it going just like that. So that means that's the sort of graph I should see when I graph it myself. Now I'm going to go to my table, get my list of values from -5 to 5. So we're going to copy them right off the table and into our paper. So -5 is a -45. 0, 21, 24, 15, 0, -15, -24, -21, 0, and 45. Now we have to decide how we're going to count in order to graph this. I got to make it to -45 and 45 on my y-axis, counting my spaces. There's 25 spaces, so I could count by 2 so that we're not all squished together. For the horizontal, I only have to get from -5 to 5. There's plenty of space though, so we can either count by 1 or we could count by 1/2. I'll keep it simple and just count by 1. So we have -5, -45 to begin. So we're coming over to -5. And counting by 2s down 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 45, and in between them. Then the point, -4, 0. -3, 21. So again, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And will be between 20 and 22. 22, 24, negative 24. And then negative 115, 2, 4, 6, 8, 10, 12, 14, 15 right there. 0, 0. And then 1, negative 15. Yeah, between 14 and 16. And 2, negative 24. 3, negative 21. 22. 4, 0. And last 5, 45. And finally, we have to connect our dots. So remember, it's a curve. It should be smooth and continuous. That wasn't very good, so I'm just going to try again. And it should not be pointing. And we're stopping at the dots because, again, we were told to stay on this interval from negative 5 to 5. So you should not go past those particular points when you do your graph. And we still have to label. So now for the domain of that function. Okay, we're not looking at the entire domain because, again, we were asked to only look at the picture in this area, which means, yes, we have all round numbers, but we have to restrict. We are only looking in this spot. This is my x's, so it's just from negative 5 to 5. As for the range, again, these are the types of answers we can get. We're not looking at the entire graph. Again, we're just looking in this area. You know, range goes with y, so we're looking at our types of answers. We're getting that from over here. So I would look, where's my lowest answer? Where was my highest answer? And I can see that I went from negative 45 to 45. Next up, we are looking at relative maximum for this particular function over this particular area. So again, think about where do we find a maximum? Well, it's at the top of the hill. So we would be looking over here at this point. You can get it off our table or off our graph. That high point was at negative 224. So that's our maximum. Relative minimum will do the same way. It's still over this interval. And it's at low point. We could always get it off our table. That point is 2, negative 24. For the last part, we have to determine where it's increasing and decreasing. So rather than doing this one at a time, I would do it same as I taught you before, going from the left side to the right side. So before I begin, I want to make sure some of those nice numbers are there to help me out. We're not going to negative infinity this time. That lowest point where we're starting is at that x value of negative 5. Remember, we're kind of coming off our table. The interval only wants the x's. So here, our x is negative 5. And then we come and we are clearly increasing until we get to that maximum point, which was when x was negative 2. Then we decrease till we got to that minimum where x was equal to 2. Then we increase again. And stop here where x is 5. So that's going to be how we will do our intervals. And looking at that left side, from negative 5 to negative 2, I am increasing. So from negative 5, put less than x, less than to negative 2, I'm increasing. First time I used a negative 5, first time I used a 2. So they both get an equal sign. Now I come back. Okay, so we just did our increasing from negative 5 to 2. So now I'm coming to this next section and decreasing from negative 2 until 2. So come back to my decreasing area from -2 until 2. I am decreasing. I already used the -2 down here, so I don't want an equal sign, but that is the first time I use a +2. I put the equal sign. And then coming back up, I am increasing again from 2 until 5. So come back to increasing, and from 2 until 5, I increase. I already used the +2. First time for +5, it gets an equal sign, and then it's done. Looking at our next page, your graph is not actually complete. We're answering the following questions about this particular graph. So you need to go through and make sure you label the points A, B, C, and D before we can do any of the questions. Then looking at 1A, which points, A, B, C, or D, are relative maximums? Again, I know maximums are at the top of the hill. A and C. Then which points are relative minimums? Bottom of the valley, B, and D. For these intervals, for part C and part D, we have to determine where it's increasing and decreasing. So what we're going to do is practice going through and estimating our particular values. We're not restricted to a particular spot this time, so on the left, as it's going down, it's going to continue to go out in the negatives on the x-axis and approach negative infinity. On the right, it's going to continue to work its way outward, approaching all the positive values, so approaching positive infinity. And then for these points, I'm mainly concerned with my x, finding out what they are. This turning point, nicely halfway between 1 and 2, so my x is 1. We're going to continue figuring out the x values for these other maximum and minimum points. Moving to B, I can see that it is between the 4 and the 6, much closer to the 4, I estimated about 4.2. C, between 6 and 8, much closer to the 8, I estimated about 7.5. Supposed to be just about halfway between that 10 and 12, so I'm going to estimate an 11. And now we're ready to do our intervals. So starting on that left side, which way am I moving? Starting on this left side, which direction am I moving? So I can see I'm moving up. I'm increasing from what to what? Well, I started increasing at negative infinity, and that continued until I reached the 1. First time I've used 1, I put an equal sign on it. Now I'm at a turning point. I'm changing direction. Now I'm decreasing. Decreasing from what to what? From this 1 to 4.2. So I'm going to show decreasing from 1 to 4.2. And that's the first time I use 4.2, I put an equal sign. Change direction again, and I am increasing. I can see I've increased again, starting at 4.2, ending at 7.5. So I write it down from 4.2 to 7.5. And because that was the first time I used the 7.5, it gets an equal sign. Change direction, I'm decreasing again. From where to where? Well, from 7.5 to 11. From 7.5 to 11, first time I use the 11, it gets an equal sign. And lastly, increasing from 11 on forever. So from 11 to infinity, plus or minus infinity, never gets. And so that is all finished. So the homework, I'm only having you do number 1, A through D. It's all the same process. Remembering it's an approach negative infinity on the x-axis from the left, positive infinity from the right. Figuring out what these turning points are. You have to list your maximums and minimums, and then your intervals for increasing and decreasing. And I would suggest writing the x values at those turning points just to help you with those intervals. If you have questions, ask for help. And we'll see you for the next lesson.